Hey everyone, and welcome back. We're continuing our discussion about recursion and how we can implement recursive methods by looking at a few of the classic situations. Once you understand the basic recipe for solving problems recursively, this gets a lot easier. That basic recipe goes as follows: base case, smaller case, combine. If we can follow those three steps, there's a really good chance that you can solve any and all recursive problems. Let's take a look at three different scenarios. We're going to do a summation problem, we are going to do a reversal problem, and we're going to do a counting problem to see how recursion can help us solve each of these scenarios. The first problem that we're going to look at is summing an array. Let's go ahead and make an array, an int array, nums, and let's put, the order doesn't really matter, just a bunch of numbers in there. There we go. Let's also make a summation variable so that we will be able to print out summation of the array is, and we can print out our sum. Perfect. Let's go ahead and get this summing array method written. Now, without worrying too much about the parameters and how I know what I'm allowed to choose and stuff like that, we'll look at that in the next video. Let's just pass in a couple of different pieces of information here. If we think about a for loop, if we were doing a summation over a for loop, we would of course need the array, and we would need the sum variable, and we would need our I index. Since we're returning the sum variable, that leaves the array and the index to come into our method here. So let's go ahead and write this method. Public static int summing an array. We're taking in our array of numbers, so we'll just call it nums in here, and we're taking in that index I, just as we did as if this was a for loop. So let's consider our different scenarios here. Well, if we're going to start at 0, and we want to consider that base case, next case, combined sort of situation here, we know that we need to stop when our sum and our index and our num length are the same. Just like a for loop would stop once the I was equal or greater than nums.length. So we could say if nums.length is, I guess we should do it the other way. It'll make more sense, I think. If our index is greater than or equal to nums.length, we want to stop. Now, in the smallest situation, we understand that we'd pass in like an empty array or an array of size 0, and then our index and our nums would already be the same, and so our summation should just be 0. Perfect. Otherwise, what do we need to do? Well, we're going to need to increase our sum variable by whatever value is currently in the nums array, and we need to go and look at the next value, summing an array, nums, index plus 1. Please note that I am not doing index plus plus, and that's on purpose, and because of the way that this will get processed, index plus plus actually won't give us the answer we want. It will get passed in to summing an array before the arithmetic of plus plus happens. That's just because of how the machine interprets plus plus instead of plus 1. There are other ways to solve that problem, but for right now, just note that I do use plus 1, and that is on purpose. After we have gone ahead and gone through our entire array, summing up all of our pieces, we can return our summation. Let's go ahead and give this a run and make sure that it works as expected. Whoops. That always happens. There we go. Perfect. And if that's correct, we can take a quick look. We've got 15. We've got 15, that's 30, and then here's the leftover 6. So 36 is the right answer. Sorry if my mental math there looked a little bit weird. You may have noticed that we start off our int sum is equal to 0, and if the index is greater than or equal to nums.length, it basically just stays as 0. So yes, we could make this smarter by negating this if statement and combining everything just like this, and that solves the problem in the exact same way. I'll just run it to prove that I am not lying. There we go. And it still works. Really good plan would be to also, test out, of course, different size arrays, make sure that this still works as we would expect it to, no matter what, passing in an empty array, all the different things. It's always a good idea to sort of make sure our code makes sense across all those different use cases. And that's it. That's all there is when it comes to summing an array. The next one that I want to show off is reversal of a string. Now I am actually going to just erase this. So if you wanted to keep this code, it's a good time to take a screenshot or to pause and write it out yourself and make sure that it works. Hello, reverse me. All right, whoops. Now the reversal of string is a little bit trickier than using numbers, just because of sort of what we might expect and how we'd expect it to work. String reversal, word, and then system .out.print reversal of, let's just put the word in here. Word is reversal. Okay, string reversal, and let's pass in our string word. Okay, so the first thing you might think to do is actually to do the same thing as we did before, perhaps realizing that what we do need to actually do here is go backwards through our string. So you might want to pass in, instead of passing in 0, you might recognize, oh, it's a reversal. So we're going to want to pass in length -1. And then we could do something actually very, very similar to what we did before. We could say, actually, we could even do it going forward. Both would work. I'll show you this way, but feel free to go and actually pass in 0 and try to write that code as well. Reversed starts off as blank. If our I is less than 0, right, because we're going backwards through our array, if it's less than 0, we want to return blank. That means we're done. Else, we want to, I guess this should have said reversed equals, just to keep with my same sort of standard writing as I had before. Otherwise, we need reversed to be equal to the current letter that we are looking at, the I, so word.char at I, plus string reversal, word I -1, because I'm going backwards. And then at the end, we can return reversed. So this is very similar to what we did before. I'm now going backwards through the string instead of forwards. Both would work, just like going backwards through the array previously would have worked as well. I just chose to do it this way. So let's just make sure that this works as we expect it to. Java, oh, we've got some, oh, I just called it reverse. My bad. Okay. Oh, it needs to have brackets, because of course it does. Now it's compiling. There we go. Reversal of hello, reverse me is, and it worked. Perfect. So we can see that this actually did work. Now is a good time to pause and try to go through it from index 0 to the front, because it's going to help you understand what I'm about to show you next, which is that instead, we can actually just pass in the word. Because a reminder that strings are actually immutable. And this is going to help us a lot right now, because what we can actually do is using substring, pull characters off of our string and only worry about once the word.length is 0. Once we have an empty string, we can actually just say reversed is empty. Otherwise, we can grab the last character, word.char at word.length, whoops. What's going to be the easiest way to do this? I can do this even smarter. That's okay. I can grab that last character, and then I can actually go ahead and say word.substring, starting at 0, and then going up to, but not including that last character. And what this is going to do, I keep forgetting those brackets. What this is actually going to allow us to do is if the word was just hello, the first character we would grab would be O, plus we would do the string reversal on all letters between 0 and the last letter, but not including it. So that gets passed in. Then it would go again, where we'd peel off an L and pass in hell with one L. Here we go. Then we would peel off an L and pass in he. We'd peel off an E and pass in H. We'd peel off the H and pass in blank. And then we'd start building our way back up. So we would end up with H plus blank, right? So really just H. And then E plus H would get put into, like, the H plus blank went right here. The EH plus blank went there. The LEH plus blank went there. The LLEH plus blank went there. The OLLEH plus blank went right there. And then it would get passed back up as, of course, hello. So we can actually do this without a counter variable at all, which is really important for us to remember. We can do that with strings using substring, and super important hint, we can even do something like this with numbers using modulus. Let's give this a run and make sure we get the same answer. Okay, I don't actually need this anymore since this only takes in one variable now, right? There's only one argument, so that looks good. Let's make sure that this compiles perfect and runs, and we get the exact same answer as we did before. So that works beautifully. We can totally check this out. So there's lots of different problems that we can solve with string reversals, like palindrome checkers, natural string reversals, and count, even not necessarily a reversal, but a counting of the characters on a string, which counting is the last example that we are going to go check out. So let's move right on to that next example. Instead of doing a string reversal, let's do a string count. Let's say int count equals string count, system.out.println, number of characters in the word is going to be count. And let's go ahead and try this out. Now, once again, we can employ the same sort of tactic, only instead of constantly returning a string reversed, we want to return a char count. And it will start at 0. And when our word length is 0, our char count is going to be 0. And then hopefully it's already very obvious to us what we need to do here. And what that is just instead of adding the characters on backwards, we're adding up the count of each character. So with each call, we need to just add 1. Let's go ahead and pass that back. It's actually really easy, given what we've already looked at. And there we go. This is a lot of characters. Apparently it's 18. I'm not going to sit here and count each one. I'll just use something that's like shorter, like this, where I can say, ah, yes, that's going to be 6 characters. And I can guarantee that it's 6, just like that. So that's it. Those are the 3 main sort of methods that you might come across, especially when you're just kind of starting out with recursion. So we had summations, we had string reversals and manipulations, and we had counting. If you're looking for a challenge, I have 2 challenge problems that you could try. The first is writing an is palindrome. So a Boolean is palindrome string word. That's the first challenge. And then the other challenge is to count, or let's do even more of a challenge. String get binary value of some number. So turning some number that's in some number that's in decimal into binary. That one's really tricky. So if you're looking for some practice problems, there's 2 that you can work with. Now, we do have some common pitfalls, of course, when we're dealing with these things like forgetting to make our case smaller so that we can work our way toward a base case. As we've said before, forgetting our base case happens. And also doing like a lot of expensive computations can really slow us down. Like, as we know, substring can actually slow us down quite a bit. And in my previous example, I had called substring 3 or 4 times in this tiny method, but we're going to look at those efficiencies in later videos. So I'm not going to fix it right now. The last thing I'll show before I close out is a reminder that since my base case is exactly the same as me initializing this variable, I could just change this to say as long as my word length is greater than 0, and just let that continue going. And it will work all the same, and I've made it smaller. And there we go. Hopefully that pattern is starting to get locked in. Base case, smaller case, combine. We can see all those things sort of playing out here. And in our next video, we're going to discuss helper methods and how we can make sure we're writing smarter and faster code. Thanks, everyone.